determine the required load calculation for a home addition, several factors must be considered according to the National Electrical Code (NEC). For an existing service, the connected load method is typically used. This involves summing the loads of all existing appliances, lighting, and other electrical equipment. However, the inspector might want to limit you to the 240-volt portion of the service, which is not usable for 120-volt loads. For the added load of the 1673 square foot addition, the floor area method is an appropriate approach. According to this method, the calculation involves allocating a certain amount of amperage per square foot for lighting and receptacles. The standard calculation is 3 volt-amps per square foot, which equates to approximately 6 amps per square foot at 120 volts. For lighting and receptacles, the calculation is as follows: 1673 square feet multiplied by 3 volt-amps per square foot equals 5019 volt-amps. To convert volt-amps to amps at 120 volts, divide by 120. 5019 volt-amps divided by 120 volts equals 41.825 amps. This represents the additional load for general lighting and receptacle circuits in the new area. It can also be seen as 5.19 kVA. A similar calculation can be done assuming 1.5 volt-amps per square foot at 240 volts for other loads in the house. In this case, 1673 square feet multiplied by 1.5 volt-amps per square foot equals 25 or 9.5 volt-amps. To convert volt-amps to amps at 240 volts, divide by 240. 25 or 9.5 volt-amps divided by 240 volts equals 10.45 amps. This is equivalent to 2.5095 kVA. It's important to note that the maximum continuous load for a 100 amp service is typically 80 amps according to standard electrical practices. To determine if the existing service is adequate, you need to calculate the total connected load. Firstly, add up the connected load of the existing service. This involves identifying all the existing electrical loads such as appliances, lighting, and fixed equipment, and summing their respective ampacities. Secondly, add the calculated load for the addition as determined by the floor area method described earlier. Finally, compare the total connected load to the maximum allowable load for the existing service, which in this case is 80 amps. If the total connected load exceeds 80 amps, it indicates that the existing service is insufficient to handle the increased electrical demand. In such cases, it becomes necessary to upgrade the service to a higher ampacity rating to accommodate the additional load safely and reliably. A service upgrade would typically involve replacing the existing service panel with one of higher capacity, as well as upgrading the service entrance conductors and possibly the meter to meet the new load requirements. At minimum, the service would need to be upgraded to 150 amps. Other specific loads must be considered separately. The 30 amp air conditioning circuit should be included in the connected load if it is powered by the 100 amp service. The 220 volt general use receptacle should also be added to the calculated load. These receptacles are intended for higher power devices, and the load contribution must be factored into the overall calculation to ensure the service can handle the demand. A jacuzzi tub is not included in the standard floor area method calculation. Instead, its load must be calculated separately based on its specific electrical requirements. This typically involves determining the ampacity of the pump motor and any heating element associated with the tub. The load of the jacuzzi tub should be added to either the connected load or the calculated load, depending on whether it is an existing fixture or part of the new addition. The shop area should be calculated using the applicable NEC tables and guidelines. The NEC provides specific requirements for calculating the load of shop areas, which may include considerations for lighting, receptacles, and any specialized equipment used in the shop. It is important to consult the NEC to determine the appropriate load calculation method for the shop area based on its intended use and equipment. When calculating the load for general use receptacles, it's important to consider the demand factors that may be applicable as outlined in the NEC. Demand factors allow for a reduction in the total calculated load based on the assumption that not all receptacles will be in use simultaneously. The specific demand factors will vary depending on the type of occupancy and the number of receptacles installed. For a dwelling unit, the NEC typically allows for a demand factor of 100% for the first 10 kVA of load and 40% for the remaining load. For example, if the total calculated load for general use receptacles is 15 kVA, the demand load would be calculated as follows: 10 kVA multiplied by 100% plus 5 kVA multiplied by 40% equals 12 kVA. In addition to the general lighting and receptacle load calculated using the floor area method, it's also important to consider any specific lighting loads that may be present in the addition, such as recessed lighting, track lighting, or decorative lighting fixtures. The load of these fixtures should be calculated based on their wattage and added to the overall lighting load for the addition. Similarly, any dedicated appliance circuits in the addition, such as those for refrigerators, dishwashers, or microwave ovens, should be included in the load calculation. The load of these appliances should be determined based on their nameplate ratings and added to the overall load for the addition. When calculating the load for electric heating systems, such as electric baseboard heaters or electric furnaces, it's important to consider the total heating load of the system. This typically involves determining the wattage of each heating element and summing them to obtain the total heating load. The NEC provides specific requirements for calculating the load of electric heating systems, including considerations for diversity factors and non-coincident loads. For example, if the addition includes two 1500-watt electric baseboard heaters, the total heating load would be 3000 watts, or 3 kVA. This load should be added to the overall load calculation for the addition. When calculating the load for electric vehicle charging equipment, it's important to consider the ampacity of the charging circuit and the voltage of the charging equipment. The NEC provides specific requirements for calculating the load of electric vehicle charging equipment, including considerations for demand factors and non-coincident loads. For example, if the addition includes a 40 amp, 240 volt electric vehicle charging circuit, the load would be calculated as follows: 40 amps multiplied by 240 volts equals 9600 volt amps, or 9.6 kVA. This load should be added to the overall load calculation for the addition. When calculating the load for permanently connected motors, such as those for well pumps or swimming pool equipment, it's important to consider the full load current of the motor and the service factor. The NEC provides specific requirements for calculating the load of permanently connected motors, including considerations for overload protection and conductor sizing. For example, if the addition includes a 1 horsepower well pump motor with a full load current of 10 amps at 240 volts, the load would be calculated as follows: 10 amps multiplied by 240 volts equals 2400 volt amps, or 2.4 kVA. This load should be added to the overall load calculation for the addition. It's also important to consider any other miscellaneous loads that may be present in the addition, such as those for security systems, home automation equipment, or audiovisual equipment. The load of these miscellaneous items should be calculated based on the wattage or ampacity and added to the overall load calculation for the addition. Once all of the individual loads have been calculated and added together, the total calculated load for the addition can be compared to the capacity of the existing electrical service to determine if an upgrade is necessary. If the total calculated load exceeds the capacity of the existing service, an upgrade will be required to ensure that the electrical system can safely and reliably handle the increased demand. The process involves summing up all the individual loads, applying any applicable demand factors, and comparing the resulting value against the service's capacity. It's important to ensure the service can handle the new demands. Firstly, one must account for all general use loads like lighting and general receptacle circuits, calculated using the floor area method. Secondly, consider the nameplate ratings of all appliances like air conditioners, refrigerators, and other motor-driven equipment. Thirdly, any electric heating such as baseboard heaters will have its amperage be taken into account. Demand factors, as stipulated by the NEC, allow for a reduction in the overall load calculation based on the diversity of use. This recognizes that not all loads operate simultaneously at their maximum rating. These factors vary depending on the type of occupancy and the number of appliances and circuits installed. The NEC provides guidelines for applying these demand factors to different types of loads. Once the total load, after applying demand factors, is determined, it's compared against the existing service capacity. For 100 amp service at 240 volts, the total capacity is 24 kVA. If the calculated load exceeds this value, a service upgrade is necessary. It's important to remember that the service capacity should not be exceeded to ensure safety and reliability. Exceeding the service capacity can lead to overloaded circuits, voltage drops, and potential fire hazards. A service upgrade involves replacing the existing service equipment with higher rated components. This includes the service panel, conductors, and meter if necessary. The size of the upgrade depends on the magnitude of the overload and the anticipated future electrical needs of the home. In some cases, it may also be necessary to upgrade the utility transformer serving the property to accommodate the increased load. This requires coordination with the local utility company. Throughout the entire process, strict adherence to the NEC is crucial. The NEC provides comprehensive guidelines for calculating electrical loads, selecting appropriate wiring methods, and ensuring the safety of electrical installations. Local building codes and regulations may also impose additional requirements that must be followed. Consulting with a qualified electrician is highly recommended to ensure that the load calculation is performed correctly and that the electrical installation complies with all applicable codes and regulations. An electrician can assess the existing electrical system, perform the necessary calculations, and recommend the appropriate service upgrade, if needed. They can also ensure that the installation is performed safely and in accordance with industry best practices. By following these steps and consulting with qualified professionals, homeowners can ensure that their electrical systems are capable of safely and reliably handling the increased load of a home addition. This will not only provide peace of mind, but also protect their homes and families from potential electrical hazards. Proper load calculation and service upgrades are essential for ensuring the safety and functionality of any electrical system. These steps are critical for all electrical installations. The existing service size is 100 amps. The new addition is 1673 square feet. There is a jacuzzi tub, a 30 amp air conditioning circuit, two 220 volt general use receptacles, all gas appliances, a new shop area for DIY, and a new master bath and bedroom. The additional load for the 1673 square feet can be calculated using the floor area method. With the floor area method, the calculation is 3 volt amps per square foot for lighting and receptacles. So 1673 square feet times 3 volt amps per square foot equals 5019 volt amps. 5019 volt amps divided by 120 volts equals 41.825 amps. For other loads, the calculation can be done assuming 1.5 volt amps per square foot at 240 volts. 1673 square feet times 1.5 volt amps per square foot equals 2509.5 volt amps. 25 or 9.5 volt amps divided by 240 volts equals 10.45 amps. The maximum load for a 100 amp service is 80 amps of continuous load. If the total connected load exceeds 80 amps, an increase of the service to at least 150 amps will be required. The 30 amp AC circuit should be added to the connected load if it is in the 100 amp service. The 220 volt general use receptacle should be added to the calculated load. The jacuzzi tub is not included in the floor area method calculation, but must be added to the connected load or calculated load as appropriate. The shop area should be calculated using the applicable NEC table. The NEC table contains specifics for each type of shop areas with tools and equipment. The steps to determine if the existing 100 amp service is sufficient are: firstly, calculate the existing connected load; secondly, calculate the additional load for the addition using the floor or area method; and thirdly, add the existing connected load and the additional load to determine the total load. Finally, compare the total load to 80 amps. If the total load exceeds 80 amps, the service must be upgraded. The NEC requires that all electrical installations be performed in a safe and workmanlike manner. The NEC provides specific requirements for conductor sizing, overcurrent protection, and grounding. The NEC also provides requirements for the installation of electrical equipment in hazardous locations. The NEC is updated every 3 years. It is important to consult the latest edition of the NEC when designing and installing electrical systems. The electrical inspector has the final say on whether or not an electrical installation is compliant with the NEC. The inspector can require changes to be made to an electrical installation if it does not meet the requirements of the NEC. The inspector can also shut down an electrical installation if it is deemed to be unsafe. It is important to work with a qualified electrician who is familiar with the NEC and local building codes. An electrician can help to ensure that an electrical installation is performed safely and in compliance with all applicable codes and regulations. When performing a load calculation for a home addition, there are several factors that must be considered. Firstly, the size of the addition is a major factor in determining the additional load. Secondly, the types of appliances that will be used in the addition are also a factor. Thirdly, the number of lighting fixtures that will be installed in the addition is a factor. Fourthly, the number of receptacles that will be installed in the addition are a factor. The NEC provides specific requirements for calculating the load of various types of electrical equipment. It is important to consult the NEC to ensure that the load calculation is performed correctly. The NEC also provides requirements for the installation of electrical equipment. It is important to follow these requirements to ensure that the electrical installation is safe. If the total calculated load exceeds the capacity of the existing service, it will be necessary to upgrade the service. A service upgrade typically involves replacing the existing service panel with a larger one. It may also be necessary to upgrade the service entrance conductors. It is important to work with a qualified electrician when performing a service upgrade. An electrician can help to ensure that the service upgrade is performed safely and in compliance with all applicable codes and regulations. In summary, calculating the electrical load for a home addition requires careful consideration of several factors. The size of the addition, the types of appliances that will be used, the number of lighting fixtures, and the number of receptacles all contribute to the overall load. The NEC provides specific requirements for calculating the load of various types of electrical equipment, and it is important to consult the NEC to ensure that the load calculation is performed correctly. If the total calculated load exceeds the capacity of the existing service, it will be necessary to upgrade the service.